Hello everyone, my name is Yesenia Enciso and this is Meteorology Part 3 homework. Today's topics will be over the lifting of air and its importance. Number 2 would be formation of precipitation and the differences between rain, snow, sleet, and hail, and also the 4 weather fronts. The lifting of air can be described as mechanisms that forces the air in the atmosphere to rise. There are 4 mechanisms as to what causes an airlift: convective, frontal, orographic, and conversion. But today we are only discussing 2 of the processes that lift air. The first one we are going to talk about is known as frontal wedging. A frontal wedging occurs when colder and denser air creates a barrier against the warmer and less dense air. This causes the warm air to rise. Frontal wedging usually occurs in Central North America. Frontal wedgings also have the tendency to create massive storms that lead to heavy precipitation. Next is convective lifting. Convective lifting occurs during warm, sunny days. Unequal heating of the Earth's surface can cause this type of lifting. It happens when an air parcel becomes warmer and less dense than the surrounding air. Because the warm air parcel is less dense, it is forced up and forms clouds. Convective lifting is associated with short and widely scattered rainfall. So why is the lifting of air important? The lifting of air is important because it contributes to the formation of clouds and precipitation. It helps our vegetation grow. Our second topic is the formation of precipitation. In meteorology, precipitation is any product of the condensation of water vapor that falls under gravity. Precipitation can come in many forms such as rain, snow, sleet, and hail. There are 2 processes that form precipitation. The first one is collision coalescence and the second one is aggregation. First, let's talk about the differences between rain, snow, sleet, and hail. Rain are just water droplets. Sleet is rain, aka water droplets. However, before they reach the Earth's surface, these water droplets freeze. Snow are ice crystals that fall. They are formed in below freezing temperatures and will remain as snow as long as temperatures stay below freezing until it is able to hit the ground. Hail is a product of high updrafts formed from cumulonimbus clouds that have freezing temperatures. Water droplets collide with one another and begin to form hailstones. So the first process of the formation of precipitation is known as collision coalescence. This is when water droplets are larger than 20 micrometers. When the water droplets fall and collide with other water droplets, they drop faster. Once the water droplets are large enough, they will be able to fall to the surface without completely evaporating. Collision coalescence can come in the form of drizzle, rain, freezing rain, and sleet. The aggregation, also known as the Bergeron process, requires ice crystals and supercooled water droplets. Supercooled simply means liquid water that remains in a liquid state even below freezing temperatures. Within the cloud, ice crystals and supercooled water droplets collide, and the ice crystals will grow in size. Once the ice crystals are large enough, they will fall in the form of snow or rain. The last topic we are going to talk about is called weather fronts. A front are boundaries that separate different air masses. It is seen as a transition zone between two air masses that have met. The first front we are going to talk about is known as a cold front. And a cold front is when warm air masses meet a cold air mass. The colder air replaces the warmer air. Cold fronts usually come from northwest or west and are accompanied by towering clouds. The cold air is pushed under the warm air. Blue will represent cold air and red will represent warm air. The warm air cools as it rises. So what typically happens is that forceful lifting of the air allows water vapor to condense into clouds. And these clouds cause heavy precipitation as well as high wind speeds. What is commonly seen with cold fronts are thunderstorms. The next front we are going to talk about is called a warm front. And with warm front, that is when warm air comes into territory that was formerly covered by cooler air. So warm air above the surface pushes above the cool air mass, making cirrus clouds. And this one, green will represent cold. Cirrus clouds are made through the adiabatic process, and cirrus clouds, the warm front also creates storms. The temperature gradually increases with the warm front. Warm fronts also cause long and steady precipitation throughout the day. The next front we are going to talk about is known as a stationary front. And a stationary front is when warm air meets with cold air, but neither the warm air or cold air is strong enough to push against the other air mass. When the warm and cold air meet, they create clouds and fog. It can either rain or snow during a stationary front. A stationary front will likely result in gentle to moderate rainfall. And last but not least, it is the occluded fronts, which form when a warm air mass is caught between two masses of cold air. The cold air masses move the warm air mass up, and the two cold air masses meet in the middle. Occluded fronts typically bring in strong winds as well as heavy precipitation.